Imagine a scenario where you want to visualize lots of time series curves, like these stocks where you can see the change in price from month to month. Imagine further that these curves have been grouped into subsets, like in this example, we've got a red, an orange, and a blue group. Now there's a lot of occlusion here because we have so many curves, so we might be tempted to stack the curves vertically to reduce occlusion. Now this unfortunately creates a new problem, and that is if we want to compare the y values across groups, it becomes more difficult because our eyes have to move up and down a greater distance than before. So we might come back and we might think about stacking in the other direction, horizontally. And now, of course, we have a complementary problem in that if we wanted to compare the same moment in time across groups to see how each of the groups is doing, again, our eyes have to move a greater distance than before. So we propose some new techniques to reduce the occlusion in the curves without introducing a large distance between the same x or y values. And we do this by making use of the space that there is in between the tick marks in time here. So our technique really only works well if you have a small number of moments in time in the view of interest. So if you only have a small number of tick marks, you have all this space in between the moments in time. And the way that we exploit the space in between these tick marks is we displace the ends of the segments. So let me show you. The first technique that we have is called compressed superposition. So the idea is that we take the curves, we divide them up into intervals in time, and then we compress each of the segments, each of these intervals in time. We compress them by a different degree for each group. So in this case, the red has been compressed more than the orange, which itself has been compressed more than the blue. And we have not changed the y positions of the endpoints of the segments at all. So that's important because it allows us to compare the y values of the curves. We also have only moved the x positions a little bit, so that means you can still see which month each of these endpoints is associated with. Unfortunately, one problem with this approach is that we've changed the slopes of each of the groups by a different factor, and that means you can't really compare the slopes across groups anymore. So we have another technique that we call compressed juxtaposition. So again, we're taking the groups of curves and dividing them up into intervals in time, but now we compress them all by the same amount and we place them side by side. So again, the distance between the x values hasn't changed very much, and the slopes of all the groups has changed by the same amount. So in theory, you can still compare slopes directly. Now there's one more technique which I'd like to show you. So I'll come back to the status quo view. This last technique, this third technique I'll show you is called shifted. And the idea here is that instead of creating any gaps between the intervals in time, we're going to take each entire group of curves and displace it by a different degree. So, for example, the red group, you can see here, we've moved by 2/3 of a month to the right. Just the entire group of red curves has been moved to the right. And the orange group has been moved by 1/3 of a month to the right. Now, it's hard to see what's going on here. There's still a lot of occlusion. So we have a trick to deal with that. We might increase the thickness of the curves, and then it gets more interesting if we play with the transparency. So what's going on here is, if you look at the red group, for example, the ends of the segments here are opaque, as they are here. So over here you can see what's going on with red in January and here in February. But in between these two extremities, in between these 2 months, the red segments become more and more transparent, and that allows you to see what's going on with the blue and the orange, and so on. It repeats down the tick marks. Now there's a few other options here. We can increase the number of tick marks, so you can see what the effect is there. We could switch back to the status quo view that I started with and maybe increase the number of tick marks all the way to 12. We can also switch to a cumulative set of curves. So here, instead of seeing simply the percentage of change from month to month in the stock prices, what we're seeing is the cumulative change over several months. And that means that the curves are able to move further away from the 0 y value as time progresses. So, to recap, the three techniques we're proposing are compressed superposition, compressed juxtaposition, and shifted. All three of these techniques reduce occlusion between the groups of curves.